Hello and welcome back to module number 7. We are going to talk about what is object-oriented programming and how does the term match to open source R and how R has to implement the foundation of object-oriented programming into its programming structure. But before we jump into it, I would like to let you know I open up the final project. Um, some of you already asked me about that, and so here it is. Basically, we are going to talk the focus of the creating of the package is on module number 10, 11, and 12, especially 10 and 11, where you're going to learn how to construct the R package and what does it entail, what packages you need to have in the background in order for you to generate the package. So it will be ongoing discussion, and I hope you will enjoy it because this is the foundation of the open source platform that allows users that have an idea and wants to contribute to the R movement by creating their own R packages. So this is it. I will list more information throughout the semester. We are not done yet with covering the basis, but this is what we are going to talk about, and we're going to continue this discussion, and I will share with you more information as we go along. So back to our subject and back to what we aim to do. So last module was a really module number 6 compared to module number 5 assignment. Module number 6 assignment was a little bit easier than it should be. So what you learn from it is the idea of how to apply metrics, how to generate data set inside the metrics, and how to apply math or statistical foundation into it and how it played out. I hope it makes sense. This is important because I know some of you are aiming to use the R to develop their statistical or math skills, and so the R is really open to those applications. And again, I know I am talking to a large number of students coming from different fields and different subjects, so bear with me, and if you have any requests, please let me know so I can help. Okay, back to our subject. What is object-oriented or OOP? So everything you touch in R is the idea of an object, which means that what you do is basically an object. So what are the unique about R is the ability to packaging separate but related data items into one class, and we will see that. And so it will helps us track of related variables or functions that we're going to implement. One of the things that we're going to look at is the idea of packages. How do we construct that? So the idea of object in R is part of the discussion or understanding that we need to have in order for us to do that. R classes means the same function can lead to different operation for object of different classes. So basically, I'm going to talk about object and classes today, and I will try to make it more coherent with that regard. Both of our textbooks talked about this, and if I do not cover a specific area, this will be a good resources. So the idea of we are going to talk about is today giving a class to more specialized class in order for us to fit that. So R, as I said before, has a system of OOP, which is based off generic function. Talking about the functions, I will tell you a bit of story. This is the old book of R that listed all the functions in the world, and it was back in 2015, and everyone who wanted to do R had to do that. Nowadays, I will share with you is the R reference card. It allows us to list all the functions that you do. There is three different sheet that I'm going to share with you. Some of them are more detailed, some of them are less detailed. And again, this is a list of all the function, plotting, statistics, regression, and so on. This is from the R base. This is how you're going to create a loop, while loop, how to read the variable, metrics, etc. I think I refer that in Canvas, but we will continue talking about that throughout the semester. And one of the things that you're going to do in your final project is create your own function. So, an object is an instance of a class. So, a generic function is a function which can be decided based on your wants and needs, and the generic function usually generate a generic concept such as plot, mean, sum, and so on. The generic function do not actually do the computation. And that's a really important thing that I want you to understand. It does not, but it gives us a slide or a bridge in order for us to do that. So a method is the implementation of generic function is an object of a particular class. So the R object, which can store data, is a member of different classes and can be used different functions to operate them. So example of an object, again, can be list, can be metrics, that can be even data frame. A common attributes of R is a class, which can be the type of object, what properties it holds, how he behaves, how he relates to other objects, and it can be the mode, which is the store mode of the type of object, and the type of is the internal descriptor of R. And the method is a function associated with a particular type of object. So what is R object? This is what makes the R unique compared to Python, any other programming language that is commonly used. We have two types of object. One is S3 and the other one is S4. S3 has a classes and method from the beginning. It is informal method. S4 is classes and method that was developed later, and it is more formal methods. So the object names is a case sensitive, consider letters or numbers, cannot obtain space, as I told you about the no of R, and we can start using it. So testing an object type and method, my object, and I'm going to create an object. When we test S4, it will test as S4 and it will modify it based on what the S4 stands for. So it will give you a character. It can also become a vector in that sense. So our object, the mode of Z is determined automatically by the type of thing stored in Z, number, characters, etc. if it is a mix or mode or a list. The class of Z is either set by default on how it is created, and it is specifically set by you as the user of R. You can check the object class and change it if you are using other people's packages, and you can check and see the change the class within the function itself. So what is class and what are the method? A class is abstract definition of a real object. So a method, in comparison to a class, is a function that performs specific calculation on the object of a specific class. So generic function is used to determine the class and its argument and selected the appropriate method. A generic function is a function with a collection of methods. More specifically about classes and method under 4, it is a good lecture by Frederick Lynch, and I saw his lecture on the subject, and again this is a good background on the subject and idea. I took his notes and I composed it into this. So he says that class is a software abstraction of a real world object. A method is a function that performs an action of data that can be an object. The class reflects how we think about the object and what information they contain, and the method defines how a particular function should behave depending on the class and its argument. An object is an instance of a class, and the method allows the computation to be adopted to a particular class. So the definition of the structure and the class inherit and embedded into the object. The method is a generic function that is dispatcher to the class itself. This is the article I like you to read. It is programming with data, and it talks about the object-oriented programming function in R, and it's really one of the foundation. This is coming back then. John Chambers was the founder of the S language, and he continued helping the R community in its development. So what is the difference between S3 and S4 in R? In the R language, as John Chambers developed, there was two object system, non-uniform, S3 and S4, and each system used to be fairly independent of each other. So under that paradigm, S3 was an object, class, and method available in R from the beginning. So they were informed and very interactive. S4, in compared to S3, was an object, class, and method that are much more formal and rigorous, but less interactive, which is available through a method of package attached to by default since the early version of the package. Note in our textbook, they know the difference between S3 and S4 is that S3 is the older, more simple methodology, less structured version, single dispatch, and S4 is considered to be the newer, more structured, has a multi-dispatch feature that can be applied. So, what is S3? Most commonly used, can be applied to multiple data types, can be dispatched on the first argument, allow you to easily change the class of existing object, which can be bad. This is my note here. So the personal note, I would like to say S3 has no formal predefined definition. Basically, it is a list within class attributes, set some class name that is a S3 object. The components of the list become member variables of the object, following a simple example of how the S3 object of a class students can be created. So with In the beginning, in module number 2, we talked about that. We talked about the function of a set of class attributes to an object, and in this case, the class has as a name and attributes, and we can adapt to it as we go along. Using constructors to create the object is a good practice to use the function with the same name as a class, but not necessarily to create an object. This will bring formally in the creation of an object and make them look similar. You can add some intelligent checks on the members of the attributes. So example, student function and A and G, and if we will say G is smaller than 4 and G is bigger than 0, stop, and he will give us some idea of manipulation in order for us to do that. For example, Paul 26 and 3.7, it will determine that I will point out error in students Paul 26 5 because the GPA has to be between 0 and 4. And that is a simple use of the object in this case. When you're going to write your own generic functions, this is what we're going to do: print the object of class, in this case student, as the previous slide showed. It is possible to make your own generic function like print or plot. So in this case, the print function has a function which contains a data set, which is use method is a print, and in byte decode with the environment. So in this case, it will already embedded what it is consist of. So this is what we talked about, generic function and how they operate in our environment. So we can see from the list, we can see that we have a single call to use method with a name for the generic function to pass it to. This dispatcher function will handle all the background details. It is the simple to implement a generic function. So if I will say use the function, this is the background of what's going on in the background. Okay, back to S3. So S3 asks us to define the class. It allowed us to create an object, build from a list, set a class attributes. It also asks us to refer a member variable, which is a $, implement generic f, defined f dot class name, and declare generic as use method. This is how the S3 works in that environment. In example from our textbook, he says he declare what it is and defined it, and he give us attributes and with a name in order for us to come up with that. We can have extensions. One line extension, and again the class equal foo, and you will see that the foo basically allowed us to have more attributes. In this case, when I declare or I call the S$ class, he will say employee. In comparison, the SR is a little bit safer. It's more checked for us if we have more errors, and is dispatched on multiple arguments, which might be a good thing, or on the other hand might be a bad thing. I know I'm contradicting myself, but you will see that in the textbook example on that. It does not allow us to easily change the class of existing object, which might be a good thing. So comparison S3 to S4. So define class, it is implicit, but S4 is set class and it requires. In S4, when we want to create a new object, you need to create it. We need to declare that saying new, and we need to give it a name. Reference number variable in the S3 is the $sign. In S4 is the @, which you're going to see in a lot of packages how they play around S3 versus S4. Implement generic F is define the F class. In comparison to S4 is set a method. Declare generic is use method, and in S4 is use generic. So S class is defined using the S class function. In our terminology, the member variables are called slot. So while defining a class, we need to set a name and a slot along the class of the slot in order for it to work. So set a class, employee, representation, the name, the character, salary, generic, and a union is basically on the logic. Is it logic or non-logic? So in this case, an example from that textbook with regard to the S, a new student, name, age, and GPA. And in this case, he will give us what it will hold with regard to his age and the GPA. More function under S4, you can check if the object is S4 through the function of S4. If it will come back and say, yes, it's true, you have a S4. Another function is to set class. It returns a generator function, so it can be used to create a new object. This function is also acts as a constructor. So a student set class, student, slot, name, and character, and in this case, I generate a class. Writing your own method. When you use a set method function plus implement a method for the show generic function, basically you are creating a new function. So in this case, a function object, a cat, which is an object name, a cat object age, which is the age year, and a cat GPA in that case. So accessing and modifying, we can use the $sign as a slot as the object access using @ and in this case S at name will give us the name that this container or this object holds. I hope that makes sense. Modification through reassigning, again the slot, and to modify it and how it played out. A slot function, similar slot can be accessed or modified using the slot function, and this is the modification. Again, this is based on our textbook reading. So the object S for S3 and S4, LS list of all current object, RM is remove object, save object that can be loaded later, class and mode give more information on the structure of the object. Existence is the return true or false depending on the example. Extension example is in our textbook that has many examples to extend throughout the creation and elaboration of the S3 versus the S4. Looking at the creation and method of S3 and S4, create both S3 and S4 object. Test the object type using the type under a specific R package. Display the object, call the variable within the S3 and S4 using the $ versus the at for each slot that you know about that. So step 1 in the assignment. There is a package, and so you're going to install a package, and one of the function, the creator of the function call created is OType, which is a function that allows you to test an object, will return that object type. You cannot do that unless you have the library embedded into the R environment that you are working on. So again, create a method of S3 example, and the next slide will be a secondary example. And again, this is from the textbook. Is NA a function eats breakfast first, which will be true. My favorite is cereal. Me, list of has breakfast, eats breakfast, favorite breakfast, and my favorite. So I compile everything. The author of the textbook compiled everything and gave us a function. He declared the class me, append class me, North America, return me, and this method is called for the S3 object. Another example, again, modifying it a little bit, and you can use ATTR method also to modify it. So again, create your own object, display the content, call the variable inside the object, and display the object. He will say to you, is it an object and what type of object it is. Then let's go to the S4 environment. And this case, again, I'm defining, and I'm also discussing the issue of validity of the function that the S3 does not has. So in this case, if under if conditions and return else in order for us to validate. So basically, validate the values that generate from the S4. So in this case, create an S object, I'm testing it, display the object, and I'm using the library from the package in order for me to show what it is. So it creates another S object and modifying it according to it. That's it. I hope you enjoy it. I know it's a little bit more complex subject, so I did not go ahead, but I want you to have a clear vision of S3 and S4 with regard to your functions, because one of the things that you will be tested in your final project and from this assignment moving forward is your function. Is it S3 or S4? And I think this is the foundation of R. I hope you enjoy it again, and let's have some more fun.